Let's talk about inequalities. The first set is set of solution to this system of inequalities. Um, Here it tells you that y is between, let's write it out again, y is between x squared and 2 minus x squared, and then x is between -1 and 1. Take that inequality, make it equal sign to find the boundaries. So y equal to x squared and y equal to 2 minus x squared. And then x equal to -1 and x equal to 1. So these are the boundaries, and some of them may be included in there, some of them may not be. Let's graph x and y. And so the point is to see what region this inequality is going to tell us. Here, y equal to x squared is going to be this one, a parabola going upward. And then y equal to 2 minus x squared, it's an inequality going downward. So at 2 and it goes downward. Oh, this is getting interesting because I can see that if I draw in y direction, I can see that this region in between these two graphs, actually y is between x squared and 2 minus x squared. And I typically put an arrow to know the x squared graph is going to be on the bottom, the other 2 minus x squared, y equal to 2 minus x squared is on the top. So the arrow tells me that. Now, the other part is that, well, this situation doesn't hold after you hit the intersections. So let's find the intersections. So intersect y equal to x squared with y equal to 2 minus x squared. And that gives me x squared is equal to 2 minus x squared, or 2x squared is equal to 2, or x squared is equal to 1, which is giving me x equal to -1 and x equal to 1. And then going back to the bounds, I see that the x equal to -1 and x equal to 1 was mentioned. So they were thinking to cut off not further than that. So the inequality can be defined. So now the next thing that you want to do is, now that with the arrow and confirm with the endpoints, you know the region, you want to shade the region. And that's the region that is mentioned in here. That's all the points into D, such that x is between -1 and 1, and y is between x squared and 2 minus x squared. Now let's talk about this one. There's a new notation in here, by the way. This means in. So here it says x and y are in R2, so they are in the plane, and y is between -1 and 4, and x is between y squared minus 4 over 3 and y. So let's write it down again. X is between y squared minus 4 over 3 and y is between -1 and 4. Let's graph these boundaries. So boundary 1 is x equal to y squared minus 4 divided by 3. Let's basically, this is going to be a parabola in the x direction. And then the other one is y equal to x. Let's graph these so that the more interesting boundary. The other two boundaries are y equal to -1 and y equal to 4 boundaries. And so in here, x and y and 1, and then this one is y equal to x, like that. And then here is a parabola, and it's looking in, opens up in this direction. if I plug in y equal to 0, I get negative 4/3, so somewhere around here is the x-intercept. And then if I plug in x equal to 0, I get y equal to 2 and y equal to negative 2 right here. Now, let's draw an arrow to figure out here. I want this graph to be that part, y be bigger than here, y squared minus 4 divided by 3 equal to x. So I want x to be bigger than that. So it starts from here, and then I want it to end at x equal to y. So the arrow goes this way, and that works. That's the lowest, that's the highest in the x direction. The other thing is that I want to make sure that this intersection, we're not exceeding this intersection points, because then the order changes. So if I have, if I intersect these two, I can say y is equal to y squared, or minus 4 divided by 3. So y squared minus 4 is equal to 3y. So y squared minus 3y minus 4 equal to 0. That gives me y minus 4 times y plus 1. And that's minus 4 plus 1 is minus 3, and they multiply to minus 4 equal to 0. So it gives me two answers. One of them is 4, the other one is negative 1. So these two are actually negative 1 and 4. So this other boundary also works. Now let's shade the region again. We're not exceeding the intersections, and it's right here.